Hello. In this mini lecture, I will be continuing with Karnaugh Maps Minimization. Look at this truth Karnaugh map. It is a kind of truth table for function f of four variables a, b, c, and d. And as you remember, and here, these values are not consecutive in a binary system because it is gray code which is used for a and b, so a 0, 1, 3, 2 instead of 0, 1, 2, 3, and the same is here, gray code and gray code here, so it is very important. And you must be aware that these values are not consecutive in terms of truth table. So for example, here I've got of course row 0. Here is row 1, ABs are first, yes, the higher bits, and CDs lower bits are lower bits. So 0 is here, 1 is here, but here is 3, 2 is here. Okay, then you've got 4, here you've got 5, but 6 is here, and 7 is here. Then you must skip, and 8 is here, and 9 here, and 10 and 11, and row 12 is here, row 13, and then here you've got 15, and here is the 14. So the rows are mixed because of the gray code used in columns for columns and for rows. And what about neighborhood? As you remember, the common edge, but you must be aware that the neighborhood is treated as toroidal as well. So, for example, this is the same edge as this one. So these are neighbors. The extreme ones are also neighbors. This is common for the group of these two and these two. So you've got a group of 4 because of the toroidal it is very important, toroidal neighborhood. But the rule is the same for these 4 ones, treated as a one group. You are scanning the values for A, B, C, D, looking only at these variables and leaving them here in the product, which values are constant for all the elements in the group. A is 0, let's start with A. A is 0, 2, but 1 here, so no A here. B is 0 for the 2 and 0 for the 2, so B is present, but because it is equal to 0 for all of them, dash must be put, okay? Okay, then C. C is also the same, yes? Look at these. For these two, C is 0, and also for these two, C is 0. So, times not C. Okay, what about D? D changes. 0 here, 1 here. So, there is no D element, D variable in this product. And that's all. Okay, and that's all. So we must add to this another group. It seems that another group is this with this glue, with this on the same, based on the same rule, but it is not true. Okay, because these are also neighbors with the above ones, the top ones. So the group, the second group, is the following: 1, 2, 3, and 4 again. Okay, these are because of the toroidal neighborhood. It is very difficult for the beginners, for students to remember about it. Okay, to remember it and to glue the extreme ones. Not only the pair, but 4 of them are neighbors. So making the same as before, looking for the variables which are constant for the 4 elements, I can see that A differs, here A 0, here 1, but B is the same. So again B with dash, because it is 0. What about C? C here is 0 and here is 1, so no C here, but D is 0 for the 2 and the bottom 2. So D, and again D is 0, so we must put dash, and that's all. It is equal to F. We found the minimal version, the cheapest one in terms of implementation. The function can be implemented using 1, 2, and as it turned out, F actually doesn't depend on A. Okay. You can see formally there were 4 variables, but if we minimize the function, it turned out to be independent of A. So to learn minimization using Karnaugh Map, I propose using Buldeusto software I put on my website. So you can download it, run it, and learn. Okay. Of course, the even better way to learn is to learn with your partner, with your mate, okay, or a group of mates, and share your results and correct your errors mutually. But if you are alone, you can use this software. Let's do the same using this software. So let's name the function f. As we had, the number of inputs, as you can see, are 4, A, B, C, D, and the same are proposed by the software. And the output, and let's say F again. Let's name it fun. Okay, the output is F, and we are going to learning mode. Okay, draw loops. Okay, incorrect in number of, okay, this is the number of 1, sorry. The combination defined date. Okay, so now we'll be filling in a manual truth table. And in order not to make mistake, look at the red labels here, 0, 0, you've got 1. So double click twice to have 1. If you click once, you've got 0. So the second row, row number 1, you've got 1. Okay. Then you've got 0 for 2, 1 for 2, because it's a different order. For row 3, you've got 0. For row 4, you've got 0, 5, 0, 6, 0, and 7. 0. Then you've got 8 here, 1, 9, 1, 10, 1, and 11, 0. 12 is here, 0, 13, 0, 14, and 15, 0. Okay, that's all. Evaluate. We'll finish our work, and then you must go to drawing loops. You can see the same truth table, Karnaugh map here, having 6 ones in the same places, okay, the same place. So let's do minimization. You simply click on to get it in red, okay, and then create loop. We'll show you the loop. It is a single loop, okay, not two separate, one containing 4 elements. Okay, and then you've got another loop, create loop, okay, and then evaluate. And if you get this kind of message, everything is correct, and you can go to accept. Okay, and then you can see the circuit viewer or the minimized equation. Sum of products, we got it. It is a sum of products, as you can see. So you can go here, and you've got not B, not D, plus not B, not C. And that's exactly the same we have here. But you can see here as a symbol use another symbol, okay, for inversion. You've got this. As you can see, it doesn't depend on A, and you can see the circuit, okay? The circuit is here. So it is the sum of two products containing the variables which are inverted first, okay? And A is not present. The circuit doesn't depend on A, even if there is an input A. All right. So please do more examples, okay, using the software, but of course, because in the exam you will have the paper and pencil, so do the same using paper pencil method, not only rely on the software. The software will teach you, but your task is to do it not using software, okay, using paper and pencil. Okay, that's all. Thank you.